Alright, our next example. What do you think about this? This is going to be the one where we have to have 2k pi because it's clear to see this is not theta by itself in the case like just this. So these are the ones we like to see, and these are the ones we're like, oh no, that's going to be a lot of work. Not that they're so difficult, but it just means more work, right? So we start these particular ones by saying, where is the sine of theta equal to 1? So our first thought is the sine of theta equals 1 at what value? We've done this one a minute ago. Sine is the y value equals 1 at pi over 2, and then all the multiples, all the 2 pi multiples of that. So, okay, so pi over 2 plus our multiples of that, 2 pi multiples of it. So let's take what's in our 2 theta parenthesis minus pi over 2, and we're going to set that equal to pi over 2 plus 2k pi. Okay, now when we're solving this equation for theta, the first thing we want to do is get this by itself. So we're going to add pi over 2 to the other side. Whatever you do to one side, you do to the other. Now I'm just going to go ahead and line this up with the other pi over 2 just because it looks like it's going to be an easy addition there. So 2 theta, what's pi over 2 plus pi over 2? A half plus a half is just pi. Good. Bless you. And then you just have 2k pi left. Alright. Now we're still wanting to get theta by itself, so what do? Divide everything by 2. So let's do one more step. Divide everything by 2. Divide everything by 2. So theta is equal to pi halves plus k pi. Alright. Out of room over there, so let's do k equals -1 over here. So that's going to be pi halves plus, we'll let k be -1 times pi. So that's going to be pi halves minus pi, which is going to be negative pi halves. Alright, let's do if k is equal to 0. So that would be pi halves plus, which that's just going to be pi halves. Do k equals 1 and k equals 2, and then check your answer. Okay, now I didn't have to do 3 because I'm already at 2 pi plus something else. So whenever I'm determining which one of these satisfy my conditions, not the negative value, so this one and 3 pi over 2 is going to satisfy. This one's outside of my region, so my solutions are just pi over 2 and 3 pi over 2. Alright, this next example is use your calculator in radian mode to determine theta. So we're looking for theta that satisfies the sine of theta is equal to 0.74. Well, the only way we're able to do that is to use our inverse function to find what theta is. And I want you to recall that, let's come off to the side and I'm going to say recall our property that sine inverse times sine of x is equal to x, right? So if I take the sine inverse of both sides, I'll have that property. So if I say, let me put sine inverse of this side, leave my sine of theta there, is equal to, and if I take the sine inverse of the other side of 0.74, then the sine inverse of them, the sine gives us just what? Theta, and that's what we're looking for by this. Let me box this off over here. By that property, and we've done this a couple of times. So this would just give us theta is equal to the sine inverse of 0.74. Now go to your calculator and we can plug this in. So you'll go to second sine, plug in 0.74, and it should give you an approximate value, which is 0.83307. So decimal 83307. If I rounded this to two decimal places, this would be round here, look at the next value. This 3 is not 5 or higher, so this stays at 3, so it would be 0.83. Okay, now that is the sine inverse, which the sine inverse only gives us the angle from negative pi halves to pi halves, right? That region to the right side of the unit circle. But sine, our original equation is sine of theta. Let's think back to this. All students take calculus. Where is a sine of theta value positive? It's positive in quadrant 1, but where else is it positive? Quadrant 2. So this one only gives, because we use sine inverse to get us, this one only gave us sine inverse is defined here. So it only told us this one. There's one more out there. So how do we find that? We could take pi and subtract off that value, right? So we could say to find the other one, we would say theta is equal to pi minus 0.83307. Let's not round until we get to this part. So, which is approximately 2.31. So the answers for these two answers will be when theta is equal to 0.83 and when theta is equal to 2.31. Okay, using a calculator, we want to know the values for where the tangent of theta is equal to 22. Now, we need to know theta, so we're going to use our tangent inverse property. So we're going to take the tan inverse of this side and the tan inverse of this side so we can plug that in the calculator. So to see that written out, I would say tan inverse of the left side and multiply tan inverse of the right side. And this property, tan times tan inverse, just gives us theta. So theta is equal to tan inverse of 22. Here's where we go to the calculator. So go to your calculator, plug that in, and we get approximately 1.53. Okay. Well, tan inverse is defined by what region? Let's remember. So it's pi over 2 to negative pi over 2 for the inverse function, right? So if we say all students take calculus, and that's just going to give us, we're looking for where ultimately our goal is to find where the tangent of theta is positive. So where is the tangent of theta positive? It's positive here, and it's positive here. Now tan inverse is just this the right side of our unit circle, so it only gives us this one. We need to also use information to get the other angle theta, so I would just say since this is pi on the unit circle, I could say pi plus that value. That's one of the ways. So the other theta, which would be in quadrant 3, would be pi plus 1.53. So when you plug pi in your calculator, add that, you should get approximately 4.67. So the 1.53 and 4.67. Cosine theta is negative. So first of all, we're going to use our cosine inverse property, multiply both sides by the cosine inverse, and that would give us this, the cosine inverse times the cosine property just gives us theta is equal to the cosine inverse of negative 0.58. Be careful not to forget that negative sign. When we plug that in the calculator, we found out that theta is approximately 2.19 or 2.18953, round it to 2.19. Okay, now cosine inverse is what portion of our graph? Cosine inverse is from here to here, which that's only going to give us one of those values. So we need, let's say, all students take calculus. The cosine function is negative in which quadrants? Well, if it's positive here and it's positive here, that means it's negative here and here, right? Well, cosine inverse is defined on the top portion, so the cosine inverse gave us this angle, so 2.19. We need to get this one, but since it's one way we could do it is we could take this 2 pi over here and subtract out that value, since this is in the second quadrant. So 2 pi and subtract out that value would give us 2 pi minus our 2.18953, or the approximate value is approximately 4.09. Now you may want to use the full decimal while you're calculating and wait to estimate at the end, and I think that's what I did. So our solutions are 2.19 and 4.09.